This section, we're going to talk about properties of proportions. So we'll kind of go through here. First one is kind of just the reciprocal, which basically means if I have a proportion, two fractions that equal each other, if I flip one of the fractions, so I flip 2 and 3 here, so 3 to 2, then I just flip the other side, right? Because it has to be equivalent, equal sign. Means whatever I do to the one side, I do to the other. So if I flip this fraction, I have to flip the second one as well. And we can check that. If I just multiply these two, right, that'd be 12. And I multiply these two, it'd be 12, right? 12 equals 12. After I've done flipping them, if I multiply these two, I still get 12. And I multiply these two, I still get 12. Right, so it'll work. So that's the first property. It's just the reciprocal. I just flip both sides, flip both fractions. Okay, second one is I switch the means, right? So these ones right here are the means. They're the means right there, so they just switch places. And so these two just switch places. It's only B and C here. So for this one, it'd only be 3 and 4 switch places, and we can check that. So they're right here, they switch places. And if we multiply these two, we get 12. We multiply these two, we get 12. So we're still getting that multiplication of 12. And then when I multiply my extremes, I still get 12. I still get 12. So you can see how those are still equivalent. So that's just by switching the means. So you have reciprocal, you have switch the means. And then the last one, I can rewrite these fractions. I can add something to the numerator, but I only add what is the denominator. So the denominator is b, so I add to the numerator b. That means on the other fraction, I have to add that denominator d to that d. So you can see here we have 2/3 equals 4/6. So I'm going to add 3 to 2. And then on this one, I have to add 6 to 4. And we'll see that these are right. So when I multiply these two, I get 12. When I multiply these means, I get 12. Okay, and we'll see what we get here. So 2 plus 3 is 6. So 6 times 6 is 36. It's not the same as 12, but you'll see it's still equivalent. Because then when I multiply these two, 4 times 6 is 20, is 10. Oh, that's 5. Oops, almost messed up there. Well, I did, I guess, 5. So that's 30. Then when I multiply these two, 4 plus 6 is 10. 10 times 3 is 30. So see, I still get an equivalent statement. Different numbers, but I still get equivalent statements. Okay, so that's adding the denominator to the numerator on both fractions. All right, so let's do a problem real quick. So I'm trying to figure out which one to use here. So I have 6 over 7 equals y over 7. What ratio completes the equivalent? All right, so I want to make this true. So basically, what happened to this fraction? How did it get switched to this side? X over y. So what changed here? So it looks like the y came down, so the y went here. So that means the 6 would have to go on top here, and the 7 stayed in place. So that would be switching the means. So property 2. I switch the means. And so it's still 6 over 7. Okay. So that's how I can set it up. Okay, so you're doing the same thing here. You're using this right here to guide what is happening. So look at this side, and how did it change here? And then you have to do the same side to that. And then this one, looking at this side, how'd that one change to this right-hand side? And what should the other side be? What should the left side be? So go ahead and try that on your own, and that's the last video.